Apologies for that video getting paused. I meant to hit pause, but I hit stop by accident. So this is part two of this video. So what we're going to be looking at here is we're going to be finishing up again the graphs that we were sketching with our hand, if you recall. So again, we did A and C together, and then I was going to do letter D with you. The reason why is because this one's kind of interesting. This one is what we call a double root. So the double root itself, as you can see, the single root passes through just the x-intercepts. Now what this one's going to do is it's actually going to bounce off. So again, we talked about how, again, when we have two roots, again, we got to indicate it somehow, and we end up bouncing it off that part there. So what we're going to do is we're going to go ahead and take a look at that, and how we're going to do that is we're going to go ahead and draw the graph. So in this case, if I look, I have those x-intercepts there that are at least going to be graphs. So one's going to be at -7 and a +7. And since, again, it's a double root, we have 2 here and then 2 there. That's an even function. So there's a total of 4, which means then what's going to happen is I'm going to end up facing, again, on the same side with those. So in this case, again, one's going to be up here, and then another's going to be up here. So what's going to happen is we're going to bring it down, and then it's going to bounce. So it's going to kind of come off of it, and then it's going to bounce one more time, and then kind of come up. So as you can see, it doesn't look like a normal function, but again, it's still a function, and it's still a polynomial. It bounces off those values. It's an even function, so it ends on the same side, and it's positive orientations. Therefore, again, it ends up there. So again, just kind of considering these graphs, again, just kind of practicing with them is going to be very beneficial. So you can go ahead and do letters B and E to kind of practice with those. And then, again, if you want me to check, I can check those later for you. But with that, we're going to go ahead and go to problem 827. So it says, look back at your work you did for 811, problem 8.2. So these were the graphs that we were talking about. And answer the following question. What is the maximum number of roots a polynomial degree 3 can have? Sketch an example. So hopefully you figured out by now. The leading term is going to tell you how many roots it is. So if it's a degree 3, right away we know it's going to be a maximum of 3. So in this case, again, it'll always have that value of 3 no matter what. And again, we can have 3 roots. All you would have is just those 3 x-intercepts. So again, just make sure you understand that. And then letter B, it says, what do you think is the maximum number of roots a polynomial degree n can have? Well, in this case, again, there can technically be unlimited there, because in this case, when you have that value, again, as you kind of increase and you go along, you'll have more numbers that can, again, be either a double root or a triple root, or just a single root. And again, the higher degrees you go, again, obviously the more x-intercepts you'll have. So, but in this case, you can have n of those. And then again, for letter C, it says, can a polynomial of degree n have fewer than n roots? Under what conditions? Well, in this case, again, what we were talking about, or excuse me, can a polynomial of degree n have fewer than n roots? In this case, actually, this is a yes. So this is saying that basically, if you have a polynomial of degree 3, can we only have 2 real roots? So in this case, what you're going to notice is this can be yes because, and we're going to talk about this kind of coming up in the next couple of days, this is yes because of what we call complex roots. So complex roots are what we call imaginary numbers or complex numbers, and these do not actually cross the x-intercept. They actually they basically kind of change the degree of the function, but you won't actually see them. And we'll figure out how to solve for them as we kind of go along. All right, 828. This is the next one here. It says, for each of the polynomial functions shown below, state the minimum degree of the equation that it can have. So in this case, we're just looking at the minimum here. What you should notice is, for number 828, again, we're going to figure out how many they can have. So in this case, if I'm looking here, it says, all right, for number 1, what's the minimum number of roots it should have? Well, since it's an odd function, both of them are going to end on the opposite sides. And since, again, it looks like we change directions here, so we come up 1, then down, and then through, the minimum number we're going to have for that one is 3. So it's an odd function, and that one there. All right, number 2. Hopefully this one's pretty easy. This one is just 2. Looks like a parabola, and pretty much is a parabola, so therefore, again, we'll have those 2, and it's negative orientation, so one of these, again, would be, or the value out in front for that polynomial will be negative. Number 3, this one's the value of 4, and again, the reason why is because it ends on the same side, and again, as you can kind of see, we kind of pass through 1, 2, 3, and then 4, so again, if we were to kind of put that as x-intercepts there. All right, and the last one for number 4, that is 5, so in this case, again, as you can see, we have, again, the tails ending on opposite sides, and again, we kind of change direction, so we go 1, 2, 3, 4, and then 5, and then we kind of come back down. So in this case, again, we're able to kind of have those values. And then for 828A, it says which of the graphs above show that the x values get very large and the y values continue to get larger and larger. So if we're looking here, we're saying as the x values get very large, meaning again as we go to the right, which ones does the y values get larger? So hopefully you can figure out, well, these are the ones that are going to end up. So in this case, again, 1 and 3 are going to be those options. So 1 and 3 will be those options there that the y value will get really big very quickly. And then for letter B, how do you describe the other graphs? Well, in this case, as the x values get larger, the y values get smaller. And this is, again, the definition of what we were talking about with positive orientation and negative orientation. So, again, as those x values increase, again, the tail is going to end up. So in this case, again, positive, they end up. Negative, they end down. All right, so again, don't think too much about this. Again, most of you, again, are pretty well adept at determining positive and negative orientation. All right, with that in mind, go ahead and go to our last couple of problems here. So in this case, 829. It says for this one, it says they have the same, or for 829, for each graph of a problem 828, you decided which the minimum number of degree for the equation could be. Under what circumstances could the graphs look the same as these polynomial equations increase to a higher degree? So consider the graphs below. So it says y equals x minus 1 counting to squared, and y equals x minus 4 to the 4th power. How are these graphs similar? How are they different? Well, in this case, they're going to have kind of the same general shape. Again, they're both going to end on the same side because they're even functions, so I would denote that. I would say, hey, they're even. And then also in this case, again, they'll kind of have that same shape, so you can kind of say same general shape. Now, the only difference with this one, when you have something to the 4th power, in this case, if you put it in your graph, actually, you can put this in your graphing calculator, and I'll kind of put this in here for you kind of to see. So in this case, when I plug it in, you're going to have that function first of y minus 1, or x minus 1, quantity squared. And then the other one, which in this case is x minus 1 to the 4th power. What you're going to notice is when we graph it, here's the quadratic, and then there's the other one. So in this case, as you can see, I'm going to make this camera a little bit better so you can see it hopefully. Well, in this case, it's a little harder to see, but in this case, what you're going to notice is the red line right here kind of comes and flattens out more at the bottom, and then it goes up at a faster rate. So in this case, that x minus 4 to the 4th, or x minus 1 to the 4th power, I should say, goes up at a faster rate. And that kind of makes sense because, again, anything to a higher power is going to be multiplied quicker, so therefore it's going to go up quicker. All right, and then for letter B, it says, could the equation from graph number 2 from the previous problem be a degree 4? Well, in this case, hopefully figured out with this one for number 2, hopefully figured out, could it be 1? It actually could be in this case because, again, it could technically bounce off. So therefore, for 829B, we could say yes for that previous problem because, again, we don't know how many times it passes through. We're just stating the minimum number. So therefore, it could be the double root, and then it bounces off for both of them, just depending on where it is. And then for letter C, could it have been a 5th degree? Well, in this case, no, because if we look at it again, number 2 here, this one right here, they end on opposite sides, so that, or excuse me, on the same side. So therefore, it guarantees it's an even function no matter what. So therefore, again, it could not have a 5th degree. So in this case, it's a no. And again, because again, it would be an even function. All right, and letter D. It says, how is the graph of y equals x cubed similar or different to y equals x to the 5th? Again, as you can probably guess, again, the rate in which they go up more quickly. So in this case, again, x to the 5th goes up at a quicker rate. And it's, again, very similar to the idea of to the 4th power and something to the 2nd power. And again, it kind of flattens out. And again, it's just going to be kind of a tail. So in this case, again, one side's, and if I draw it out here, it kind of obviously has one end down, and then it flattens out more and goes up at a more quicker rate. So in this case, it looks something kind of like that if you put in your graph. All right, and then for letter E, it says, how do shapes of graphs y equals x minus 2 cubed and x plus 1 quantity fifth have repeated factors differ from the shapes of graphs of equations that have 3 or 5 factors that are different from one another? So that's kind of a wordy question. I don't really like this one, but in this case, you kind of get the idea. But in other words, the polynomials that have all different factors kind of have humps, and these just bend. So in this case, again, polynomials, again, they just all have different shapes, that idea. Again, as you kind of go along, again, they'll have different, I guess you could say bounces or wiggles. That's what we kind of use. And again, these determine our kind of our triple and double roots. So in this case, again, we've kind of talked about those now a couple of times. And in this case, what it's asking you to do for 830, it says in the example of the polynomial function, so it's talking the one that we did on those graphs in the front, it says this squared factor produces what is called a double root. What is the effect on the graph? Well, in this case, again, you saw me, again, acting it out in class. It bounces off the x-axis. So in this case, again, that's just to denote that, again, there's two values there. Again, for the degree of the function, that's why it's super important. And then for letter B, it says check your equations for the triple root. What this one does, it wiggles. So in this case, it wiggles through the x-axis. All right, so what we're going to do with all this information now. So we've talked about the orientation, we've talked about even and odd, and then we've talked about, again, how a single, double, and triple root act. What we're going to do now is we're going to, without using our calculator, and I'll pull it up here, without using a calculator, we're going to sketch rough graphs of the following functions. So therefore, for letters A, B, and C, just like we kind of did with that previous problem, all the way back at the beginning of this video, we sketched those graphs with our hand or drew them on our sketch. We're going to go ahead and do the same thing here. We're going to make it a little bit more specific, just kind of make it, again, for our graph. So I'm going to go ahead and kind of plot those points. By no means, again, is it a perfect graph. If you have graph paper, please do. Again, otherwise you can just do it on this problem here. So 835, it says p of x is equal to negative x and then x plus 1, x minus 3. So the first thing I'm going to do is I'm going to obviously graph my x-intercepts. So in this case, one of them is going to be when we switch it around at negative 1. Another one is going to be at x equals 3. And the other one's going to be at x equals 0. So again, just help yourself out by writing these out, because when you do, again, it becomes a lot easier to graph. And therefore, when we do that, we're going to go ahead and graph. So I'm going to go 0. Obviously, I'm going to put 1, and then I'm going to go like 1, 2, 3. I'm going to put a dot, and if you want, you can go all the way to 5, and then I usually go to 5 on the other side as well, just kind of mimic it out. And then the other one, negative 1. So in this case, I'll put my dot there at negative 1. All right, so I've got my 3 x-intercepts graphed. They're all single roots, so there's not going to be anything that kind of bounces or wiggles. So therefore, what I'm going to do is I'm just going to have it pass through. And in this case, again, what I want to pay attention to is that negative orientation. So therefore, again, since we have a negative orientation, we are obviously going to have the tail end down at least. So in this case, again, this side is going to be ending down. And now we need to figure out, okay, is it an odd function or an even? Well, in this case, hopefully you figured out this one is an odd function, or excuse me, an even function. I said, no, odd, sorry, my bad. Because in this case, you got 1, 2, 3 roots. So therefore, what you got is you got them ending on opposite sides. So therefore, what you're going to do is you're going to have it pass through. So I'm going to go ahead and start. I'm going to have it go down. And again, you can kind of make it any which way you want. You can make it look pretty. Passes through and comes back up, comes back down, and then there's your function again. So again, if you want to, you can totally plug this into your calculator and give it a shot. But what you're going to notice is, again, they're going to be obviously not perfect, but in this case, again, we get the general shape of the polynomial. Both of them end on opposite sides. One of them is ending down because of the negative orientation, and it passes through those 3 x-intercepts there as well. So again, that's what the graph will look like for that one there. Letter B, we're going to go ahead and graph that one. This one's here, right here. So I'm going to go ahead and graph those x-intercepts as well. So therefore, I'm going to go ahead and find those, and one of them is going to be at x equals 1. Another one is going to be at x equals negative 2. And x is going to be... And then what you're going to do is you got x equals 1, x equals negative 2, and then the other one is going to be at x equals 4 there. So therefore, again, you got those three x-intercepts. What you're going to do now is you're going to go ahead and plot them. So I'm going to go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And then I'm going to go ahead and put my dots. So the first one at x equals 1, so I'm going to put a dot there. Next one at -2, so I'm going to go ahead and put that there. And then the last one at 4, so I'm going to go 1, 2, 3, 4, and I'm going to put it there. Now what you're going to notice is with that x minus 1 squared, in this case it's going to be a double root. So what you're going to have to do is you're going to have to bounce it off. So again, right at that value of 1, it's going to bounce off somewhere. And we're going to determine that here in a second. The next thing we need to talk about is, again, what degree it is. So in this case, again, there are 4 factors. So there are four I should say 4 zeros or 4, looking for the right word. It'll come to me, but 4 factors. In this case, again, it's going to be an even function. And then also what you should notice is, since, again, there's no negative out in front, we're going to have a positive orientation as well. So therefore, what we're going to do is we're going to go ahead and put those in for the function. All right, so I'm going to go ahead and put them. Since it's an even function, they're going to end on the same side. And I'm going to go ahead and draw it. So first thing we got is we got that value at -2. So we're going to go ahead and pass through there. Then what we're going to do is we're going to have that function, it's coming up at x plus 1, or x equals 1, I should say, and it's going to come and bounce off. So it's going to look something like that. And then what we're going to do is we're going to have it pass through the last x-intercept, and therefore at that value of +4. So therefore it looks something kind of like that. All right, so again, there's our second graph. Hopefully you had something that looks like that. Again, check your graphing calculator just to make sure that, again, it looks good for you. All right, and last but not least, we got that letter C. So in this case, it says x plus 2 quantity cubed, and then x minus 4. So I'm going to go ahead and make that last graph here. Now, last graph is going to look something like this. And we're going to go ahead and fill that in. First, I'm going to write my zeros. So x is equal to -2, and x is equal to 4. So there are my 2 x-intercepts there. Now, obviously, as you can see, we are going to have a triple root, so that's going to be, again, a little bit different. So therefore, we're going to do 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And therefore, what I'm going to do is I'm going to go ahead and plot those points. So the first one at 4, and then the next one at -2. And then what's going to happen is we're going to go ahead and plot them. So therefore, I'm looking, no negative out in front, so it's going to be positive orientation. And then we're going to go ahead and, again, determine, since it's a root with 3 and then one more, we're going to have it in 4th root. So therefore, it's going to be 4 factors or 4 roots. And we're going to have the value be an even function. Make sure you note that we have even or, again, roots, when we have roots or factors or zeros, we're all talking about the same thing. And last but not least, what we're going to do is we're going to go ahead and draw it in. So therefore, again, determining, since it's an even function, they're going to end on the same side. And they're both going to end up because, again, there's a positive orientation. So therefore, what I'm going to do is I'm going to go ahead and plot it. So the first thing I'm going to do is I'm going to go down. Now, with this, when we hit a triple root, what's going to happen is it's going to wiggle through. So it's going to come down and go like this. So it's going to like kind of lay flat a little bit. So it's going to lay flat and then go like that. So again, when you determine the wiggle, don't go like straight through, just go like a little side and then come on down. And then last but not least, kind of comes back up and looks something like that. So there are your graphs. Again, there's a lot of different ways you can kind of practice with these. You can kind of just sketch them on your own. And again, this is going to be on our quiz coming up in a couple of days. And it's going to be kind of helpful to kind of look and see how we kind of work through them. So this is section 812 notes. Hopefully you got a chance to, again, watch this video. Please make sure you let me know if you have any questions. Hopefully your quiz goes well as well. Again, I'm looking forward to making sure that those hopefully turned out okay. Otherwise, have a great rest of your day, and we'll see you all on Thursday. Have a good day.